Hello everyone. Today we're going to see one more problem from Blind 75 series, which is top k frequent element. Let's see what the problem asks you to do is they will just give a list of numbers and you just need to find the top k frequent element from this one. If you just don't understand the problem statement, just think like this, and you have a grocery shop with you and you just need to find which item is selling the most. You just think that this problem is similar to the same thing. You just need to find the most frequent element from this from this array, and you have to find the k frequent element. If the k is 2, you just need to get top 2 frequent element from this array. If k is 3, you need to get top 3 frequent element from it. I hope you just understand this question statement. I think it's very simple. But if you look at this input, we can observe that 1 appeared 3 times, 2 appeared 3 times, and 3 appeared 2 times, and 4 appeared one time. If you look at this, you can just easily tell 1 and 2 appeared significant amount of time, which is 3, and 3 appeared 2 times, and then 4 appeared one time, which is least significant. Now you just tell me the top 3 frequent element from this. By looking at it, you can tell the top 3 frequent element is, which is 1, which is 2, and which is 3. These are the top frequent element for this array. Hope you guys understand this problem statement. Now in this video we are just going to discuss a sorting solution and heap solution, which is better compared to sorting, and then we'll look into the bucket sort, similar kind of bucket sort, which is the most optimal one for this problem statement. Okay, now let's directly jump to the sorting solution. So before that, what we have to do is we have to create a table, or we have to use hash map, and we have to count the frequency. Let me draw out the frequency map very quickly. Yeah, I just drawn the frequency map for you guys. You can see this is going to be the key, and this is going to be value is going to be frequency. Now just fill this out. So 1 appeared how much time? 1 appeared 3 times. So just fill 3, and 2 appeared 3 times, and 3 appeared 2 times, and 4 appeared 1 time, and this is just empty space. Just leave this empty space. Now what you have to do is just make them as a pair of integer and the frequency of it. Let me repeat this. You have to make a pair of number and the frequency of it. Make this pair and store this in an array. Okay, I'll tell why we have to do this. Okay, just create an array and just store this one. 1 comma 3, 2 comma 3, 3 comma 2, 4 comma 1. Now you made an array, isn't it, with the pairs of number and the frequency of it. Now what you can do is you can just simply sort it using the first element. First element is going to be first element in the sense, in the pair, use this first element as a key and sort it out. I know you guys know to sort this thing, so I'm not going to explain how sorting works here. The basic idea, just sort the entire array with the first element with it. Now if we do the sorting, obviously this already sorted. For now let's add and pair, which is 5 comma 2, just for example right now, because it's already sorted, right? Now if we add this, this is unsorted. Now if we sort this array, we're just going to get 1 comma 3, 2 comma 3, 3 comma 2, 5 comma 2, and 4 comma 1. Now you can easily tell me the k frequent element from it. You can directly access the top k element and you can just return them as a result. Just do a for loop, have a result, and just pick this element, this element, this element, and return as a result. That's it. Very simple one. You don't have to do much things. And if I just want to write simple pseudocode for this, from this I'm writing, okay, the result is going to be empty list and just going to be for I in range. Okay, I forgot, right? I need to write pseudocode for I is going to be 0 till the k. I'm just directly going to access this sorted sorted array of I, and I need to get the zeroth element as the number, isn't it? The first element as the frequency and zeroth element as the number. So don't forget to give the 0. Okay, we directly append this to the result dot push. That's it. Return the result. That's it. Very simple solution, isn't it? If we talk about time complexity for this, it's going to be n log n, right? Because we are sorting the array, so that's the time complexity of it, and we're just going to access for k times. We can just ignore this. We can have n log n time. If we talk about space, it's going to be O of n time, because we have an additional array to store this key value pass and sort it. That's why we have O of n space. Now, if we talk about the heap solution, this it's going to be almost similar to that, but one slight changes. We are not going to sort it, because if you see heap data structure or priority queue, it's going to be sorted when you just insert the array. When you insert the value in the heap data structure. So you don't need to additionally sort the heap array. Okay. So what we can do is we can follow this similar logic, and instead of here, we can just make a small modification like result dot append. We just pop the element from the heap pop of heap, and for heap this format is going to be a little different. In this case we have number comma frequency, but while pushing in the priority queue, it need to be in the format of frequency and the number. Okay, don't forget it. Actually here also you can do like that, but for heap it should be like this: frequency and the number. So obviously the top frequent element at the top of the heap data structure, if you pop that, you can directly get that values under it. So just get it, just pop it. Again, in this case you have to access the first element, because zeroth element is going to be frequent and first element is going to be number. Don't forget to use the first element from this. I guess I confused you guys. I should have taken this like frequency comma number from the beginning itself. That's fine, that's completely fine. Right now we just changed according to the heap. For sorting it doesn't matter, because we used sorting key or sorting index to sort it. So for sorting it can be anywhere, but for heap it must be frequency, because if it will access the first element and determine it should come at which place. If we have a number at the first place, it's going to be in the sorted format of this number value, not the frequency value. So don't forget to use frequency as the first one and number as the second one. It's very simple, right? The same solution. But if we talk about the time complexity, it's going to take k of log n time, because this popping will take only log of n time in the heap data structure. You have to remember, in heap popping will take only log of n time, and we are just going to pop the k element from the heap. So the time complexity is going to be k of log n, and say space is going to be O of n. There is no change in the space, only time changes. It's not very significantly better, but it's slightly better compared to the previous solution. I hope you guys understand till this. Now we just jump into the very optimal solution. Okay, this is going to be very interesting, and for most of the people this is going to be very new, because even when I learned this, it was very new to me and it was little complex to understand, but I try to make it very clear and very easy to understand. Okay, so if you guys know about bucket sorting, that's well and good. We're just going to use the same concept for it. Now let's directly jump into the optimal solution. The basic of this optimal solution is going to be bucket sort. I'll just explain bucket sort very quickly, and then we'll utilize the bucket sort functionality to create a very optimized solution. It's going to be very magical. Okay, just stay with me. I will show you one of the best thing you ever seen so far. Okay, just stay with me here. Now let's take an example array. Okay, we can take previous one, but To explain this much better, I'm just going to make a small modification from the input which we used here. Now this is our input array, and we have to return again top three element from this. Now what we have to do is, if technically if we see in this, if we see in the bucket sort, what we'll do is we'll create an array and we'll just store the frequency of all the element from the array. Okay, all the element from the array. If we see in bucket sort, what we'll do is we'll create an array of size with the maximum value in the given array. If you see, the maximum value is 100, so we have to create an array of size 100, and then what we have to do is we have to update the frequency of the number. In this example, if you see 1 appeared 4 times, so just update 4, and if you see 2 appeared 3 times, just update here, and if you just do it, we'll just update 2, and then it's going to be empty, 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 and then 100 is going to be appear 1 time. Sorry, this should be 100, not 1000. You can see the drawback here. Again, with this we cannot able to make up our answer. Keep this thing how it works. And there's one drawback. You just have only how much elements? 7, then 9, 10. For size of 10, you just created an array of size 100, which is unnecessary space. Just assume that you have 1 million in your array. According to the bucket sort, you have to create an array of size up 1 million, but you just have only 11 element in your array, isn't it? You just have 11 items. Why you just need to create a million? Just because we are using bucket sort, we don't have to create that much, isn't it? We can use the same logic what we used here to make it better. So this is going to be values, and this is going to be count. That's what we are doing here. This is going to be frequency, this is going to be number. So just keep this logic. We are just going to use this one to make our solution very beautiful and very magical. Okay, now you just see we created an array of size 100, but what we can do is, so do you think any better way we can just do this problem? Because we're just creating unnecessary space. Don't you think that any smart way is there to reduce this thing? If you guessed it, then that's well and good. We can just reverse this process. Reverse in the sense, if you don't understand, let me draw it for you guys and then I explain to you. Yeah, this is what I mean by reversing. So in the previous one, we had value and the frequency. Now we have count and the items. So why does I make like this? And you can ask me why the size is 10. That's a good question. Definitely it's a good question. Just think, at max how much time an element can be repeated in this array we have 10 element, right? At max how much times an element can be repeated? Just think. At max it can be repeated only 10 times, right? If you take an array of size 4, at max an element can be repeated how much time? Or basically it's going to be 4. So you don't need to create unnecessary space. You can just create of size n, and this is going to be frequency count. What this frequency count tells us that how much element is going to be there with this frequency. This is going to contain this. And if you just take this 6 will tell you that how much element in this array has frequency of 6. Just keep this in mind and we can just fill this table out, right? Just help me or pick a paper and pen, just draw this table and try to solve this problem with me. Now let's fill this table. At first we just go from the first. Okay, we just take 1 and we'll see in this array which element has only one frequency. If we scan this entire array, the only one frequency is this one, right? So just put 100 here. Again, this is going to have more than one value. So use an array. This is going to have 100. And now we'll just move to the 2. So which element in this particular array has 2 frequency? Here we have 3. I guess we can add little more input number here. We have 4, we have 4, we have 5 also. And then again k is going to be 3. Now if you see, we have some changes in the input, right? For better understand, I just add few elements. Now we see 4 is also have 2, and we can have 4 here, and then 5. We forgot about 5. 5 is going to be solo guy, so we're just going to join up with this 100. Now if you look at this map, you can just understand that at the frequency of 1 we have 2 element, at frequency of 2 we have again 2 element. Now we'll just move to 3. At 3, how much element has frequency of 3? If we see in this given input, we have only 2. Number 2 as the frequent element of 3. I mean, it came 3 times. Again, we just move to the 4. If we see 4, the element 1 appear 4 times. So we just create an array with the 4. And if we see for remaining case, it's going to be empty, isn't it? No element appeared 5 times, 6 times, 7 times, even 10 times. So it's just going to be empty. Now the magic thing happens here. What we can do is we can just iterate from the backwards and pick the element from this array, just push it to the result. Okay. You can ask me, Magesh, why I should come from the back. Yeah, that's really good question. If you think and see, we need the k frequent element from the given array. Okay, to get the k frequent element, we have to access from right to left, because what this indicate 10 indicate that the most frequent element that can be appeared in this array, the most frequent in the sense it came more number of time than the other element, right? So 10 as the most priority compared to the remaining element. So that's why we just access from right to left. If you access from left to right, what does 1 indicate? 1 indicate that it appeared least amount of time. We don't need least element, we need most frequent element. To get the frequent element, you definitely need to access from the from the right to the left. If you dry run this solution, just access 10. 10 doesn't have any element. Just ignore this. Just go to the 9. 9 also doesn't have. 8 doesn't have. 7 doesn't have. 6 doesn't have. 5 doesn't have. Now if you come to the 4, 4 has 1. So just have 1 in our result array, isn't it? 1 in our result array. Again, now we just finished 4. Then come to the 3. In 3 we have 2. So just add 2 to the result. Now if you come to the 2, we have 2 values here, right? But we need only 3 elements. So just stop with 1, 2, 3 and directly return the list. It's very simple solution. What we did is we just have the idea of bucket sort. We just reverse the logic and we just access this from right to left and just append the element to the result until unless it just get to the value of k. Until it reaches the value of k length, just pick the item from the backwards and push to the result. That's it, very simple. Now let's write the pseudocode for this. It's going to be very simple. As we fill the table here with help of frequency only, we filled, right, with which element has one frequency. We just took the element and we just added to this array, right? First we need to get the frequency of every single element. I hope you guys know how to get this frequency. I'm not going to explain this code because it's very basic. It's just unnecessary time taking thing. So I'm just going to skip that part. Let's assume that counter is going to be empty, and here we'll have the code which will do this work for us, which means every element and its frequency. And next we need to have this frequency array, isn't it? This frequency array of size n, and inside that we need to have another list. If I want to tell more clearly, we need to have a nested list, right? This is going to be nested list. For that, what you can do is you can just create a nested list of size n. This is a syntax in Python. You can just use on your own language. So what this code will do is it's going to be create an array with a nested array of size n. This is how this array looks. Okay, you can create in your own language, and this is going to contain the frequency of element. 1 contain 4 times, 2 contain 2 occurs 3 times, 3 occur 2 times, 4 occur 1 time, 100 occur one time. This is going to contain this. I'm not going to write code for this because it's very simple. We just see on core logic. This thing will see while executing the code, right? Now what we have to do is we have to fill this table. How we can fill this table is just iterate to this frequency for key in counter, and then we can just get the count in the sense frequency. How we can access the count is counter of key. If you just put this, you will get the value of this current element, how much time it occurred. Now what we did here is, according to the count, we just added the element to this list. Okay, we can directly implement here. So frequency of count dot append the key. If you remember carefully, we are using frequency as our index here. Don't forget, we are using frequency as index. One indicate the element which has one frequency. So in our case, 100 as one frequency. Okay, we just push 100 to this list. Remember, this is a list, not a value. So we just put 100 to the list. That's what this append tells. If you, when this loop finish, we are going to have this entire list ready for us. Now only one thing left for us is we have to loop from the backwards. We just need to fill the result array. How we can achieve that is declare a result. Okay, now we have to access from the backward. Is it for I is going to be length of frequency, or okay, length of frequency minus 1 to the 0th element. We need to access till the 0th element, isn't it? And we have to get the element in the sense I'm talking about this is the element. So just get this. Okay, element is going to be frequency of I. So frequency of I, right? If we take this, we are accessing from 11, right? Sorry, 10. So frequency of 10 will be empty, so we are not going to do anything. So when it comes here, so frequency of 4 will be element of 1. So this is how element looks. Element is going to be 1. So we're just going to pick the 1 and put it into the list. Again, we're just going to pick 3. When I becomes 3, we'll just get this value, just put to the list. And when I is going to be 2, we just pick 3 and 4. And when you put 3, we will reach the k element, isn't it? We just need 3 element, so directly return it. So our code looks here is, I think we don't have enough space here, so I'll just write out here. Now where we left element, right? We need to access every element from the list. So for num in element result dot push, we just push the element num, and we just need to check the case if a size of result is equal to k. If it's equal to k, we can directly return result, and then just close the bracket. For namesake, just return the empty list. Obviously we'll end up in this case and we'll just return the result. For namesake, just have this. I guess in constraint they said the array is not going to be empty. Array in the sense, this one I'm talking, input is not going to be empty. So obviously our case will reach here and we'll return the result from here itself. We don't, for namesake, just return an empty list at the last. I hope you guys understand this solution. If you don't understand, just take pen and paper, just work out with me. You will definitely understand this solution. It's very good solution. Now let's create a counter which will help us to keep track of the frequency of every element in a list. For num and nums, if num and counter, just increment the counter of num plus equal to 1. If it's not exists, just have a default value of 1. And then if you remember, we create a frequency list of size n, right? Length of nums. Now next step is to fill out this frequency map. Just fill out this thing as we discussed in the video. For that, what you have to do is for key comma count in counter dot items. Actually in Python we have something called items which will pick the both count and with both key and count Now what we can do is we can directly access the count and append the key to it. If I want to print out for you guys, I can just print and show it to you how it looks. Runtime error. What is the error? Oh, sorry, it's my mistake. We have to create an array of size n plus 1. I forgot to mention there. Okay, now if you see, what this tells is frequency of 1, we have value 3. And this tells at the frequency of 2, we have element 2. At the frequency of 3, we have number 3. Okay, this is what we built in the video. The same thing we built over here. Now what we can do is, as a next step, just declare a result array and access the frequency from the reverse till the 0th element, right? Further, what we have to do is, for I in range, a length of frequency minus 1 till the 0th element, access reverse word. I mean minus 1 will indicate just go 1 back. Now take all the element. So for num and frequency of I, and then result dot append num, and then remember the base case. The base case, right? If length of result is going to be okay, just return the result. If not, return an empty list. That's it. This is what we discussed in the pseudocode. Now let's run this and see. It passed the test case. Now let's submit it. Yeah, we successfully did this problem. Again, you can try out this heap and sort solution also by yourself. We're not going to code those things out. Thanks for watching till this, guys, and make sure to subscribe so that you can get the video daily. And until then, bye.